Hello everyone, welcome to the second video on tree traversals. And in this opportunity, what we're going to do is we're going to implement the breadth first transversal using Java code. So let's take a look at that. Before we start, the code that I'm going to use is the one that we left in the previous class. In the previous class, we implemented a class called link tree, and that tree had several nodes, and not only that had several nodes, it also had we implemented in there the pre-order and in-order and post-order transversals, and we did that in a recursive way. So I'm going to use the same code as a base to start, because that means that I don't have to create the nodes again, and I don't have to create the tree again. The tree is already ready, so I can use that. So let's take a look at this. So it makes sense that wherever I have my pre-order, in-order, and post-order methods, that I can have my breadth first transversals. So let's take a look. Let's create a method in here. So public void, and I'm going to call this breadth first. This is, we all know this is traversal. Now we can approach this in different ways. So we can, for example, just the same way we did before, we can pass in the node where I want to start, but I'm actually going to assume that if I'm calling this method, I'm going to always start from the root. So I'm going to create a variable of the type node that I'm going to call current, and that current is always going to start being the root of the node. Now let's take a look at my pseudocode for a second. I know I need to initialize the queue that containing the root. So let's do that. Let's also initialize the queue. Queue, I'm going to call it queue, is equals to a new linked list. Now I'm missing a couple of things in here, so I need to define here that this queue is going to be a queue of nodes, and I need to put my diamond brackets in there. Perfect. And I'm going to add that current node, which is my root, into the queue. So I'm going to say queue.add current. So what we've done here, is initialize the queue, and the queue contains the root node. So far so good. So the next thing is I need to have a while loop. So I'm going to say while queue is not empty. So let's do that. So while, so I put the full structure, and then I can say, well, queue is not empty. So I can say queue that is empty, but I'm not looking for queue to being empty. I'm looking for queue not to being empty. So I'm saying, well, not queue is empty. And now inside, the next thing I'm going to do is we're going to say, okay, as long as queue is not empty, I'm going to dequeue my whoever is next in my queue, and I'm going to do the visit action for the position P. So I'm going to say current is equals to whoever is next in the queue would be queue.remove. And it's a good thing that we all know what a queue is. So it's a first in, first out structure. So now I can go and visit the current node. There you go. And the next thing is, yes, I'm visiting the current, so happy with that. But now the next thing I'm going to do is I'm going to add the two children of the current node. So remember, I know there is no more than two child. So so I'm going to add them both to the queue. So I can go and say if current that, and this is happening as long as those children are there. So that get left is not null. So I'm going to take that left child, I'm going to put it in the queue. Queue.add. C that get left. No seed, but current. There you go. So the next thing I'm going to do is exactly the same thing for the right child. So I'm going to say if the current that get right is not null, I want to add it to the queue. Now, this is not recursively, but still is going to keep happening, because what it's going to do is, as long as the queue is not empty, it's going to keep adding elements. Now, every time I visit one node, I will remove that node and just visit the rest of the elements that I have in there. So make sure you take a look at this code and you understand it. We can discuss that in the live class, but take a look at that and let me know. So I'm going to run this code to make sure that I'm not lying to you here. So I'm going to go back to my main object, to my main class, and I'm going to call the code, the method, my tree.bird first. Now remember, these we left this code already working. We left this code already with some nodes in there, and we created a tree using the methods from the tree. So now we can actually traverse the code. Okay, so let's run this and see what happens. There it is. My tree has been traversed in a breadth first order. Now, this breadth first order is also called level order. The next thing that I'm going to ask you is try to answer or try to figure out why is it called level order. So draw your diagram, see the order in which the elements are being displayed, and hopefully you'll see why this is being called a level order traversal. Brilliant. Thank you very much for watching, guys, and I'll see you in the next video.